Hi, this is a demo of OpenStack Virtual Baremetal running on an unmolested TripleO-based OpenStack cloud. If you followed the OVB project at all in the past, you will know that this is significant because previously OVB required a Nova patch and some custom neutron configuration, neither of which were probably appropriate for a production public cloud. So being able to run in an unmodified OpenStack cloud opens up the possibility of running OVB in many, many more places. This particular example is going to be running in just my home lab, so it's not actually running in a public cloud yet. Hopefully at some point I'll be able to do a demo of that as well, because that's ultimately the goal for this work. But for the moment, this shows the possibility of running in any public cloud that exposes the necessary resources from OpenStack. So I'll just start off real quickly by showing the command I used for TripleO to deploy the host cloud, and that's just right here. And this is pretty standard TripleO stuff. I may do a demo just about TripleO at some point because I'm not sure how well understood that is, but for the moment this is what I used. And for OVB you configure it with the env.yaml file. So here's the one that I am using for this demo, and for the most part this is just information about the host cloud, where the endpoint lives, what the credentials are, some images that need to be populated into the cloud so that you can actually boot the necessary instances and what have you. And then there's some configuration down at the bottom that's just mostly convenience. So from there we can go ahead and deploy an OVB environment, and this will be the command to do that. Deploy.py is something that's shipped with OVB in so much as OVB is shipped at all, and then quintuple-O is the kind of shorthand name for the environment that we use to deploy TripleO in test. And it's quintuple-O because it's TripleO on OpenStack. And I'm just passing an ID so that we can see that the instances and everything that get created are associated with this demo. So we'll kick that off, and what that is going to do is start a heat deployment, and we can see that here. And we will also see that there are some Nova instances spinning up. And the undercloud will be the deployment system, so that's the VM that will be used to deploy all of the other OpenStack VMs once the environment is all up and running. And we should see some more VMs being created. There we go. You can also see the BMC instance here, which is basically a fake BMC. It's based on the Pygmy project, and it allows you to control OpenStack instances like real bare metal nodes using IPMI commands, just like you would any kind of enterprise hardware. And my home lab is a little slow, so this takes a while. It would be quicker on faster hardware, of course, but there we go. Everything is active, so we should see create complete on the heat stack. So now we've got that, and the next thing we need to do is build a nodes.json file, and what we'll do with that is actually pass it into TripleO, and then TripleO will use that information to configure the IPMI settings on the ironic nodes. So in order to generate that file, there's another tool that is shipped with OVB, and it's called build nodes.json, and we'll just pass it the environment file. Now you'll notice that this is not the same environment file that we looked at before. The deploy.py command appends that -demo ID to the environment when it does a deployment with an ID, because it make some modifications. So that's the file we'll actually pass here. And you can see we've generated a bunch of JSON, and then we see a mapping down there at the bottom that's IPMI addresses to the actual instances that they're associated with. So we can see the same thing as in the nodes.json file. And this is just, again, pretty standard TripleO configuration. There's documentation on TripleO.org if you're interested in knowing more about what all this is doing, but you can see it's basically just simple information about the nodes that we've created here. And so what we'll need to do is send that file to the node that we just booted, and in this case that's this address, and we'll rename it to instackenv.json just because that's what TripleO expects. And you can see that's up there now. And one other thing I will show real quickly here is the console log of the BMC, because this is a useful thing to be able to look at. So you'll see these managing instance lines down here. That means that the BMC is up and configured and listening for the IPMI commands to those instances. And if we grep for that, we should see 6 of those, because we deployed 6 bare metal VMs. So there you can see there's all 6 of our BMCs are up and running, so we're good to go there. The next step will be installing an undercloud on the undercloud VM, uploading the images, registering the nodes, doing all of the basics TripleO stuff. I'm not going to actually include that as part of this demo, so I'm going to pause here for a moment and do all of those steps, and then I will come right back and we will demonstrate the actual deployment to the nodes that we just created. And we're back. The undercloud is now installed on the appropriate VM, and we've gone ahead and registered our virtual bare metal nodes with it. So if we take another look at the BMC console log, what we see is a whole bunch of messages about Ironic pulling the IPMI interface for the status of the nodes, which in this case is all off because Ironic shuts down nodes when they get registered. So you can see that there. Only the BMC and the undercloud are currently running. So there's just one more step that we need to do before we move on to doing the deployment of the nested cloud, and that is to copy some network templates up to the undercloud. And the reason I'm showing this and I didn't show the rest of the undercloud configuration was that this is actually OVB specific. These are some templates that are shipped as part of OVB because they match the networking environment that OVB deploys with network isolation enabled. So those are just in network templates, and we'll copy those up to the undercloud. There we go. And then we will go ahead and SSH to the undercloud. Okay, and there you can see our network templates that we just uploaded. Now there's a little bit more configuration, and again this is specific to OVB because of the way the MTUs work out. We will need to make some modifications to the networking on the undercloud. So I'm going to go ahead and become root here because this all needs to be done that way. And the first thing I'm going to do is change the MTU on the provisioning interface, and this is what will be used for pixie booting the virtual bare metal instances. So we'll just set that, and we're setting it to 1350 because TripleO by default sets the tenant MTU to 1400, and so we need to leave some room for tunneling overhead there. So now that's done. Then we also need to configure Ironic because this is a TripleO based undercloud, so we're using OpenStack services to do the deployment, and so we need to configure the Ironic MTU so that when we're doing the Pixie deployment, the iPixie image uses the correct MTU for contacting Ironic. And so we will also restart Neutron so it picks up those changes. And then just one more piece of configuration that we need to do. There's a third network interface attached to the undercloud, and that is the fake external network for the cloud we're about to deploy. And so we need to do some manual configuration on the undercloud so that we have an IP assigned to that interface, and so we can talk to the cloud we're about to deploy. So that's just like this, and 10.0.0.1 is the default gateway that's configured in those network templates that we just uploaded, so that's why I'm choosing that address for this particular instance. And again, we need to set the MTU appropriately. Okay, so if we look at our IP configuration now, you can see everything is running with the 1350 MTU, so we should be good to go. And we have configured our external interface. This is a fake external interface. It's not actually going anywhere. So we're done as root. And the only thing that should be left to do then is to kick off the deployment. So this is the deploy command I'm going to use. Again, this is pretty standard TripleO stuff. And I chose to deploy 6 virtual bare metal nodes, mostly because that's more nodes than I could deploy on any single machine that I have running in my house. So this is kind of a demonstration of the potential scalability of using OVB to do bare metal style testing like this. You can deploy a whole lot more VMs than you could ever deploy in, you know, a single box virtual environment. And so the rest of that is just pretty standard network configuration. Since we're running a nested vert environment here, we need to use unaccelerated virtualization, and that's pretty much it. So we will kick off the deployment, and then we can go watch. Whoop. Have to get access to this cloud first. Let's try that again. Oh, and let's see, I need to make a copy of the heat templates as well. So now it should work. And what we should see shortly here, and this is just standard output from the TripleO deployment process, but what we will eventually see here is that it will start to provision the bare metal instances that we had created earlier, and it will actually start those instances through that IPMI interface, and they will pixie boot back to the undercloud here. Okay, and it looks like the nodes are being deployed now. So shortly we should start to see the instances here start to turn on. And there we go. So we'll go take a look at the console of one of these real quickly. So you can see here it is pixie booting, and it's gotten a response from the undercloud. And you couldn't do this normally in an OpenStack cloud because DHCP from instances is not allowed, but thanks to some enhancements made to Neutron lately, it is possible to disable that IP spoofing protection, so we can do things like this now. So we've started the deployment RAM disk now, and we're just running through the deploy process, bringing everything up. And now what is happening in the background is that the disk image we're deploying is being copied over to the instance backing store, and so that will take a little bit, and then the node will reboot and the deployment process will continue. And so that will take a little while, so I think I will probably pause again here and pick it up again once the deployment is completed. And we're back again. As you can see, our overcloud has been deployed now and should be ready for use. We're just going to run some quick sanity checks on it to make sure that everything is actually functioning as expected, because there are some scenarios with OVB where the cloud can deploy correctly, but due to MTU issues or firewall rules, it may not actually work correctly. So the first thing we'll take a look at is, first of all, get into the overcloud, and we'll take a look at the Nova services. Okay, and we can see our controller and our 5 computes that we deployed here, so that looks good. And we'll real quickly take a look at the Neutron agent list as well. Lots of smiley faces, so that looks good too. And one last thing that we'll do before we end the demo is just a quick ping test on the overcloud. And TripleO actually provides a built-in version of this, and what it's going to do is start a heat stack that just boots a Nova instance from volume, so we exercise Cinder. A glance image will be uploaded, the Neutron networking will be configured appropriately, so we'll get pretty good coverage of the main OpenStack services with that. And so the first thing we need to do is just set some environment variables so that the script knows what it's supposed to do, and then we'll just run overcloud ping test. And again, this is something that's just validating functionality that has been an issue in the past for OVB if you weren't making modifications to the Neutron configuration underneath the host cloud. Okay, and we can see we were able to ping the nested instance, so everything looks good there. All the ping test is going to do from here is just delete the heat stack and clean up the things that it created, so there's nothing really terribly interesting to talk about there. So the only caveat that I want to leave on this demo is that right now this is not live in the OVB master branch, because it requires some changes to the heat templates that are not compatible with older clouds. So in order to maintain compatibility with Kilo clouds in particular, this is currently living as a feature branch, and it's I believe called port-security in the OVB Git repo. So if you're interested in trying this out, that's where you would find it. Hopefully we'll be able to get this into master shortly, or possibly cut a stable branch for the Kilo compatibility and make this available just as the default mode for OVB. So I think that's all I had that I wanted to show for this, and thanks for watching.